Hi, my name is Tyler Brooks. Welcome to the Directorate of Flight Safety Crash Scene Hazard Management video series. In this video, we're going to review the Crash Scene Hazard Matrix, or CraSH matrix. Previously, we introduced the DFS approach to crash scene hazard management, which is based on the risk management cycle and the 5 hazard categories. To give personnel a head start when managing a crash scene, we recommend pre-assessing the hazard categories for known or expected hazards in your aircraft fleets. DFS has pre-assessed the hazard categories for its aircraft fleets and summarized it in the CraSH matrix. Let's review the CraSH matrix, which is general enough for you to use in the initial assessment of most types of aircraft crashes. Physical hazards include broken aircraft structures, carbon fiber and other composite materials, explosives, radiological materials, and stored energy structures such as tires and gas cylinders. Most physical hazards create exposure through physical contact, resulting in cuts, punctures, and crush injuries. Inhalation can be an exposure route for specific hazards, such as burned carbon fibers and radiological materials. Exposure to radiological materials can also occur through ingestion, physical contact, and even proximity. Risk is assessed by estimating the likelihood and severity of injury or negative impact on the mission. For typical crashes, physical hazards are considered high-risk hazards because of the high likelihood of severe injury or mission impact. Radiological hazards are an exception and are typically considered low risk. Radiological hazards are often only present in small amounts. They frequently survive crashes intact, and they are usually easy to detect and isolate. Control measures for physical hazards include minimizing the number of personnel on site through strict crash scene access control, avoiding and cordoning areas of greatest risk, disarming explosives or stored energy structure, decontamination, prohibiting eating and drinking on the crash site, and wearing personal protective equipment with respiratory protection when required. Also, carbon fiber can be prevented from becoming an inhalational hazard by applying a fixant or soil tackifier of water, ice, firefighting foam, or acrylic floor wax. Chemical hazards include petroleum, oil, lubricants, metals, metal oxides, and other chemical products of combustion, such as Viton, which is released from burning rubber. Exposure to chemical hazards is usually by inhalation, ingestion, and contact. For most crashes, chemical hazards are medium risk due to the high likelihood of moderate injury or mission impact. Control measures include strict crash scene access control, avoiding and cordoning areas of greatest risk, decontamination or neutralization, which may be possible with water or a 10% household bleach solution, prohibiting eating and drinking on the crash site, and wearing personal protective equipment with respiratory protection when required. Environmental hazards include cold, heat, fatigue, insects, wildlife, terrain, and threats from enemy or other security issues. Exposure routes for environmental hazards are highly variable and depend on the specific hazards, but are often through physical contact, and sometimes depend on the length of time spent on the site. For most crashes, environmental hazards are medium risk due to the high likelihood of moderate injury or mission impact. Control measures for environmental hazards are highly variable, but include strict crash scene access control, site security, work rest cycles, feeding and hydration, insect repellent and tick removal, sunscreen, appropriate clothing, and appropriate personal protective equipment. Psychological hazards include traumatic exposures to death and injuries. Exposures can either be direct, by personally witnessing distressing scenes, or indirect, through exposure to stories told by other witnesses. The risks of psychological hazards have often been underestimated. Even non-fatal crashes can be distressing for first responders, investigators, and cleanup personnel. For this reason, psychological hazards are medium risk, even for non-fatal crashes, because of the high likelihood of moderate injury or mission impact. Fatal crashes, or those involving injury to personnel, may be considered high risk. Control measures include strict access control, work rest cycles, carefully monitoring personnel for signs of distress, limiting exposure and information release, and wearing appropriate personal protective equipment. Biological hazards include infectious diseases and bloodborne pathogens, such as human immunodeficiency virus, hepatitis B, and hepatitis C. Exposure usually requires contact with infected bodily fluids or tissues through skin cuts, scrapes, and punctures, or through mucous membranes, such as the eyes, nose, or mouth. For most crashes, biological hazards are considered low risk due to the low likelihood of severe injury or mission impact. Control measures include strict access control, decontamination with a 10% household bleach solution, prohibiting eating and drinking on the crash site, and wearing appropriate personal protective equipment. Vaccination is also extremely effective against certain infectious diseases, such as hepatitis B, and is strongly encouraged. The CraSH matrix can provide a useful head start for anyone managing crash scene hazards. Remember, the CraSH matrix can be adjusted to suit the unique conditions at the crash scene or as conditions change. For instance, hazards can be added or removed, exposure routes can be adjusted, risk levels can be raised or lowered, and control measures can be customized. Of course, we recommend that you review your own aircraft fleets for any unusual or specific hazards and make any adjustments to the CraSH matrix to suit your organization. This concludes the introduction to the DFS CraSH matrix.